Dear students, good morning. In the previous two parts, that is determinant 1 and determinant 2, we discussed the definition of a determinant for 2 by 2 matrix and for 3 by 3 matrix also. Before that one, we defined the minor and cofactor. The minor and cofactor are useful to find the determinant of a 3 by 3 matrix. Okay, now that is over. Now we are going to solve the properties which are related to the determinants. Okay, now the very first one, if A is a square matrix, then that A is equal to that of A transpose. Suppose A is a matrix 2 by 2 or 3 by 3. Both are solved here. If A is a square matrix, A transpose is also there. Then that of A transpose, both are same. We have to prove it. You see, here we have to prove A is a square matrix, then that A, we have to prove that A is that of A transpose. Let A, I am taking as a 2 by 2 matrix. Let A is A, B, C, D. A, B, C, D. Very simple example. Anytime you take like this only. A, B, C, D. Then that A, this is the notation for the determinant. That A is, it is also notation, the vertical bars. That A, that of A, B, C, D. The same elements, the position, rows, column, as it is, we have to write. It is a matrix. If curved brackets are there, they are matrix. If vertical bars are there, they are determinant for the matrix. So the same elements be written and the notation is vertical bars. Then by definition of determinant of 2 by 2 matrix, we know it. The difference of product of elements in the first and second diagonals, AD minus BC. Okay, now, so it is equation 1. That is okay. Next, what is A transpose again? What is A transpose? A transpose is equal, means the rows and columns are interchanged. AB as a column, CD second row as a second column. Okay, now already we solved in the matrix. For that one, A transpose with that, this is notation. Here also the notation for a determinant AC BD. It is also AD minus BC. Okay, now the difference of product of all elements in the two diagonals. So AD minus the same BC. So it is number 2 equation. From 1 and 2 equations, here you see AD minus BC, here also AD minus BC. So in the first equation, that is that A, and here it is that of A transpose. Okay, now that is right. So in the 2 by 2 matrix, we solved data of A is equal to data of A transpose. Now, in the same proof, I am taking the 3 by 3 matrix. Okay, now 3 by 3 matrix. 3 by 3 matrix already many times I take this 3 by 3 general matrix. A11, A12, A13. A21, A22, A23. Okay, Nana? The first number, first digits 1, 1, 1 indicates row 1, 2, 2, 2 indicates second row, third row. This vertically 1, 1, 1, second digits 2, 2, 2, 3, 3, 3. It indicates the column. Right? Then that A is it is not 2 by 2, it is 3 by 3. A different concept is there. While we are expanding the determinant, I am taking the first row only. Always you prefer to take the expansion of determinant in the first row only. A11 capital A11, A12 capital A12, A13 capital A13, because is the product of all elements of first row which are multiplied by their corresponding cofactors. Then what is A11? You try to understand it. A11 is a cofactor of A11. So it is this one. After deleting that row and column, this is the minor, and it is multiplied by minus 1 power 1 plus 1. Here it is plus 1. Very simple. It is plus minus plus 1. Okay, na? Right. So it is A22 A33 minus A32 A23. Okay, na? Next, here is a plus, of course, but you write minus. While we are solving, we are expanding A12, that is minus of this one. So I write minus here. The total minus of, not this one, this is element A12, minus in this expression is combinedly is capital A12, that is cofactor of that one. So it is, we know it well, already we saw. Again, A13, row and column deleted, A21, A22, A31, A32 is there. Okay, na? Here also it is a plus A13 of A21, A32, A31, A22 is there. Okay, na? Here. Okay, na? Right. This is it is equation 1. So this is the determinant of the given 3 by 3 matrix. Again, we calculate the determinant of A transpose. A transpose means, determinant, okay, leave it out. A transpose means this, in this matrix, given matrix, if the rows are changed as columns, first row as first column, second row as a second column, third row as a third column. Okay, na? Yeah. And I am giving the notation vertical bars, means it is a depth. Of course, I am changing the rows and columns, interchanging. That means we are getting A transpose. For that A transpose, I am taking the modulus. Say A11 into capital A11 plus A21 into capital A21, A31 into capital A31. This is the definition for finding the determinant. Here also I am taking the row only. All the elements A11, A21, A31 are multiplied by their corresponding cofactors A11, A21, capital letters A31. Okay? Here also it is a plus, minus, plus. Don't confuse. A11 as it is A11. But capital A11 means with this plus we calculate the minor. Okay, plus minor. A22, A33. Minus A23, A3. Next, minus here. It is minus. A21. This minus and after deleting this row and column, these are the elements. Okay, now A12, A33. Here is there. A31, A32 is there. And minus also is there. That plus to minus plus means minus 1 power its position I plus j. Here minus 1 with the position I plus j. Here 1 plus 1. So minus 1 power 1 plus 1 square plus is there. Here it is plus. For this one, minus 1 power first row, second column. 1 plus 2, 3. Minus 1 power 3 means minus. We get minus. That is why I am writing here minus. Here it is 1 first row, third column. 1 plus 3. That is 4. Minus 1 power 4 means it is a plus. So we get this one. A31 plus A31 Okay, now. And we will have the elements A12, A22, A13, A23. The class is there A12, A23, A31, A22. Okay, Nana? Yeah. Now, the first is as it is. Don't confuse. The first bracket is as it is. I am writing. The second one is expanded. You don't confuse. A21, A12. A21, A12, A33, minus plus, A21, A13, A32, plus. Here also, expansion, A31, A12, A31, A12, this is A12, 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 and A31, plus minus A31, A13 and A22. Okay, na? Okay. Again. So here the first bracket is as it is, the last one. And here observe me. In this expansion, these two terms is expanded. Here A12 here is there. Here also A12 is there. In these two terms, you take A12 as common. A12 as common means minus A12 is common. Then A21, A33. A21, A33. Here also, if minus goes out, this is this plus becomes as a minus. A12 goes out. Then A31, A23. A31, A23. Okay, na? Next, in these two terms, what is the common? A13 here is. A13 here also, A13 is there. Then, if you take A13 as common, A21, A32, minus A31, A22. This is A22. Okay, Nana? A22. Okay, na? You see, say it is equation 2. Now, you observe 1 and 2. Both are same. You observe me. 1 and 2. The first bracket is first bracket. Minus A12 is there. The same bracket is there. Plus A13 is there. In the inside the bracket is the same expression is there. So, from 1 and 2, I will write here. From 1 and 2, observe me. From 1 and 2, that is delta of A is equal to delta of A transfer. The first, I consider delta of A. Some RHS, that expression, 3 brackets are there. That is equation 1. And again we consider delta of A transpose. That A transpose, at last again the same steps will be taken. 3 brackets. That is 2. So it is proved. Hence it is proved. Whatever it may be the matrix A, 2 by 2 or 3 by 3. But it must be square matrix. Then the data of that matrix, square matrix, is nothing but data of its transpose. Okay, na? Yeah. Okay. The next property. Second property. A is a square matrix of order 2 and K is a constant. Then data of Ka, this is a notation for the determinant. Data of Ka is equal to K square det A. That A is itself det A. But that K becomes as K square. Here the order of A is 2. So it is K square. If the matrix is order of 3, then it is K cube. If it is order of 4, K power 4, like that. Order of n, K power n will come. Okay, na? That is the property. Now we will solve it. So let A, B, C, D is a square matrix of order 2 by 2, of order 2. Okay. And K is a matrix, a constant. K is a constant, A is a given matrix. Then K into that matrix. The multiplication of matrix with a constant K means it multiply all the elements inside the matrix. Ka, Kb, Kc and Kd. Okay now? Right. Then for that Ka is again a new matrix. The determinant is that of Ka is that of that Ka, Kb, Kc, Kd. By the rule, by the definition, the difference of product of elements of first and second diagonals. Okay now, this is Ka, Kd, Kc, Kd. So K square, here also K square common. Here is AD minus, here is BC. That AD minus BC, from the beginning, in the last video also, I told that one. The determinant of 2 by 2 matrix is AD minus BC, the same example. So here AD minus BC means that here. So we consider data of Ka and we proved that K square that. Okay now? Hence the theorem. Okay now? Right. Now the exercise. Now we are going to solve the exercise. A simple exercise. I think 6 problems are there. 6 or 7. Exercise 4.1. Evaluate the following. Number 1. Okay now? Number 1. Solutions. Number 1. It is determinant of 2, 4, minus 5, minus 1. Directly given. Evaluate the following. Directly it is a notation, determinant. Determinant of 2, 4, minus 5, minus 1. This is determinant, not matrix. By definition is 2 into minus 1 minus 5 into 4. That is minus 2 plus 20. That is 18. Okay now? It is minus 2 minus plus 5 4 20. 20 minus 2 18. Next, number 2. The first one. It is cos theta minus sin theta. It is sin theta minus cos theta. It is also with a notation determinant. It is nothing but same. The product of elements in the first diagonal, that is cos theta into cos theta minus it is sin theta into minus sin theta. Okay na? Minus the product of second diagonal elements. It is cos square theta minus plus sin square theta is equal to 1. So its determinant is 1. And we go to next. It is x square minus x plus 1. The x minus 1. It is x plus 1. It is again it is x plus 1. Okay now? It is also determinant. By definition, x square minus x plus 1 into x plus 1. That means AD minus BC. X plus 1 of x minus 1. Okay na? BC. A into D minus B into C. Here also x plus 1 is common. So we take x plus 1 as a common. Then here it is x square minus x plus 1 minus x minus plus 1 is there. Okay na? Now it is x plus 1 of This x square minus 2x plus 2 is there. Okay, Nana? Expansion. X plus 1 is common. And here x square minus 1 plus 1 minus x minus into minus plus 1. Here in the bracket x square minus x minus 2x 1 plus 1 2. Now this is x into x square x cube minus 2x square x into minus 2x square plus x into 2x. Again plus 1 with 1 multiply 1 into x square minus 2x, it is plus 2. Okay, now this is 2x cancels, minus 2x square plus 2x plus x square is there. So it is simply x cube minus x square plus 2, what we needed. Okay, now this x cube minus 2x square plus x square minus x square remains, plus 2 constant is there. That is the thing. Okay, now next. See, third one. What is third one? We are given, this is a given matrix. Given matrix A is equal to 1, 2, 4, 2. This is A. Then we have to show that. What is 2A? Then 2A is 2 into same matrix 4, 2. It is 2 into 1 is 2, 2 into 2 4, 2 4 is 8, 2 2 is again 4. We are multiplying with 2. Yeah, that is 2A. Then what is 2A with determinant, data of 2A. Then it is det 2 4 8 4. It is 2 into 4 minus 8 into 4. That is equal to 8 minus 32. That how much? It is 24. Okay, now observe. What is det A? Again, we take simply det A. Data of 1, 2, 4, 2. That matrix is taken with the notation vertical bars means det A. Here 1 into 2 minus 4 into 2. That is 2 minus 8 is equal to minus 6. Then 4 into A. 4 into det A. 4 into minus 6 is equal to minus 24. Here also it is minus 24. 8 minus 32 means minus 24. Both are same. So here mod of, det 2A is equal to 4 det A. Just like in the property K A with modulus. That means det of Ka is K square det A. K square means 2 square 4. Why? Because the order is 2 by 2. Your order is 2 by 2. That is why we get that one. Okay, now? Yeah. Next. Next, fourth one. Given matrix. What is given? A is equal to 3 by 3 matrix. 1, 0, 1, 0, 1, 2, 0, 0, 4 is 3 by 3 matrix. Okay, now? It is a 3 by 3 matrix. Now, first we find that A. That A means with notation 1, 0, 1, 0, 1, 2, 0, 0, 4. It is 1. I already told you. Again, I am telling. It is plus, minus, plus none. Always a determinant of any 3 by 3 matrix can be calculated, can be expanded in the first one. You by heart that one only. You practice in that one only. So it is plus. plus 1 of that row and column deleted, we get only 1204. Okay, now this is 1204 and minus 0 into or 0 minus must be taken, 0 taken, row and column goes, it is 0 to 04 plus 1 is there, 1 with the determinant, row and column, it is 0 1 0 0. Now how much? 1 of 4 minus 0. It is 4 into 1 4 minus 0 into 2 is 0 only. Minus 0 anything is 0. Plus 1 into this is 0 minus 0. So it is only 4. So the data of A is the determinant of A is data of A is simply 4. Now consider it is 3A. What is 3A? It is 3 into 3 into the matrix. What is the matrix? 1 0 1 0 1 2 0 0 4. This is matrix with determinant. It is a determinant is there. Like that we may follow. 3A with modulus. Directly I am taking 3A with modulus. This 3 is there, determinant is there, matrix also. 3 into 1 is 3, 0, 3, 0, 3, 6, 0, 0, 6, 4, 6, 12. Okay, now it is a determinant. So I am again, it is 0, 3, 0, 0, 3, 6, 0, 0, 12. Okay, determinant. Now, we know it. Determinant means it is plus 3. Don't confuse. Plus 3 of, you delete this one. It is determinant minor 3, 6, 0, 12. It is minus 0 into row and column deleted 0, 6, it is 0, 12 and plus 3 determinant row column deleted 0, 3 and 0, 0. Now what is 3 of? It is 36 minus 0. Minus 0 anything is 0. Plus 3 into again it is 0 in 0 minus 0. 0. So what is the answer? It is I am writing here then. It is 3 into 36 only. 3 into 36 only. 3 into 36 means that is 3 into 9 into, can you write 4? Okay, na? 3 nines 27 into 4. Okay, na? You see 3 into 36. That 36 is 9 fours. 3 into 9 is 27. That 4. This is 27. What is 4? 4 is that A. Okay, na? Like that we can solve. Okay, na? Right. Right.